Okay, let's start this session. Mm, yeah, let's start this session. Today, gravitational fields theory ගත්තම යන්නේ. Um, mm, yes, as in the tute again. Tute. I hope you have the tute printout. නැත්නම් ගොයි හෙල් ලියාගෙන printout දාගන්න මේ printout එකකින් ලියාගත්තා නම් හොඳයි. අවුලක් නැහැ. If not, yeah, we will be doing notes and then questions. Okay. So yeah, let's start the session. Gravitational fields. What is a gravitational field? What is a gravitational field? The gravitational field කියන්නේ we have two masses. Normally in the gravitational field, is considered when you have a certain mass in a empty space. When you have a certain mass, due to gravitational force, there will be certain region where there is a certain force acting on gravitational force acting on the object. This region is known as gravitational field. Okay, may object එක තියෙනකොට may there are some forces there will be forces created by this object due to gravity of this object. The places where these forces act is called as gravitational field. Okay, so yeah, mainly under the region in which attractive forces of a mass or a group of mass, the region in which the attractive forces of a mass or a group of mass act is known as gravitational field. Is known as gravitational field region in which attractive forces of a mass or a group of mass spread. Now, yeah, this will also apply for group of masses. So let's say with we have a mass capital M over here and we have a mass simple M over here. Now, the region where the gravitational field region has increased because there will be certain region of gravitational field because of this object and this object. Then we have to consider all the gravitational field, all the places or region where gravitational field acts. Next, gravitational line of force. What is gravitational line of force? Gravitational line of force කියන්නේ මොකක්ද? Now we talked about this region. We have a mass. We have a mass, and then in that mass, there's a gravitational force acting on it, and the region where the gravitational force acts is called gravitational field. Then, if we have a certain object over here, either of mass simple m or something, okay, we don't need to think about it, okay. The part in which we normally take it as path, but that is not how we take it. We have to take the what do you call the line, the path, the force x. I mean, it is easy because force is directional. Directional force is a vector quantity. Force force only has a certain certain direction. So we can directly say the path in which a point mass will be attracted to an object. ඒ කියන්නේ දැන් මේ object එක මෙතෙන් තියෙනකොට if it is at rest, it will directly move in a path connecting the two what do you call center of gravity. එතකොට මේ වගේ path එකක් නෙන්නේ. This path මෙයාව නෙමෙයි. This path is known as gravitational line of force. This part is known as gravitational line of force. So we can write gravitational line of force. So Yeah, that is what a gravitational line of force is. Shall we write the note for it? The okay, gravitational line of force. Yeah. The path of a point mass. The path of a point mass which tends to move in a gravitational field. The path of a point mass which tends to move by a gravitational field is known as gravitational line of force. Okay. Then the path of a point mass which tends to move by a gravitational field is known as gravitational line of force. හරි thumbs up එකක් දාන්න බලමු. ලියුවා නම්. ලියලා ඉවරයිනේ. ලියලා ඉවරද? The path of a point mass which tends to move by a gravitational field. So it is actually we are talking about the path of a point mass in a gravitational field. Even if it is not there, if the gravitational force acts towards this side, we have to consider that as gravitational line of force. Gravitational line of force එක මේ main object එකක් තියෙන්න ඕනේ කියලා එකක් නැහැ. Okay නේ? Also that is gravitational line of force. Now let's go to those are just normal theories. Okay, those are just normal words. They might ask for the essay, then you have to directly write as it is, as I have given in the note. Next one, Newton's law of gravitation. Newton's law of gravitation. Now, we know Isaac Newton. Isaac Newton found so many things in his lifetime. Okay, the first discovery he went through is gravitational force. Yes, he discovered the gravitational force using a falling apple. He found he found gravitational force. So what? By doing some research and all, okay, by doing some certain research and all, he found that we can say the magnitude of the gravitational force. The magnitude of the gravitational force is equals to gmm over r square. Okay, this is the gmm over r square. This is the equation for gravitational force between two masses. Now, the description for it, the description he gave for it, now write this down, right? If because gmm over r square just above the image or just on the side of the image. Image की side එකට ලියන්න අර dotted lines වල ලියන්නකො image की side එකට මේක ලියන්න. Okay නේ? The meaning, the description he gave is gravitational force of attraction between two particles. Gravitational force of attraction between two particles. එකිනෙ මේ particles දෙකක් තියෙනකොට gravitational attraction forces between these two particles of mass capital M and simple m situated in a mass capital M and simple m situated in distance r from each other can be given by කියලා මේක තමයි given. Okay, so if you get it for the exam, you have to directly write the gravitational force of attraction between two particles of mass capital M and simple m with situated in distance r is given by F equals gmm over r square. F equals gmm over r square. On making තමයි half of the questions in our yearly exam is done. ඒකින් තමයි not half gravitational field questions කරන්නේ අර equation එක තියලා තමයි. Now හරි ඒක හරිනේ. Now Yeah, so that is the equation. This is you can using this, you can find the gravitational force. But let's say what happens if we have three objects. Three objects තියෙනවා නම් මොකද්ද වෙන්නේ? Let's say M1, M2 and M3. We have three objects. Then what will happen? Each object will have its own force. මෙතන F1, F1. Um, මෙයා F2, මෙයා F2, මෙයා F3, මෙයා F3. හරිද? Now, if you want to find the gravitational force acting on one object, okay, you have to find these two gravitational force and gravitational force and resolve it using vector addition. Vector addition again. If you find the vector resultant force, you can find the Newton's gravitational total gravitational attraction. I mean gravitational force of the object. Now, මෙතන G කියන එක කවුද? මෙතන G කියලා constant එකක්. There's a constant called G. What is this G? G is called universal gravitational constant. G is called universal gravitational constant. එයාගේ units nm square kilograms nm square per kilo square kilogram. ඔන්න බලන්නකො. We have Newton. ඕනේ නම් බලන්න. If we subject gravitation what you call universal gravitational constant, we'll get F r square divided by. So if we find the dimensions of this or units of this, force can in Newton, r square can in meter square. මෙතන masses දෙකක් තියෙනවා multiplication, then they come as kilograms per square kilograms කියලා. and per square kilograms කියලා එනවා. That is the unit. Dimensions is gonna be Newton 10 m l t minus 2 l square m minus 2. Our final answer will be, what do you call dimensions? Final answer for dimensions will be m minus 1 l cube t minus 2. m minus 1 l cube t minus 2. ඒකත් ලියා ගන්න. Okay නේ? Now this is called a universal gravitational constant. ඒ කියන්නේ whatever the equation we are using, okay, whatever the equation we are using within the space, universe के कोई තැනකටවත්, if we are using this equation, if we are using an equation, and if it has a symbol called G කියලා symbol එකක් තිබුණා නම් එයාට value එක 6.67 times 10 to the power minus 11 Newton meter square per square kilogram. This is our unit. So make ඔක්කොම multiply කරාම you can directly see, you will get the gravitational force capital A. Okay නේද? If you understood, put a thumbs up. Thumbs up එකක් දාන්න බලමු. I don't know what is happening here. Okay. Now next theory එකට යමු. Next theory එකට ගිහිල්ලා next theory is gravitational field intensity. ඒ දෙකම කරාට පස්සේ there are like 15 MCQs and 2 essays, 2 small essays. Practice කරාම ඒක දැනට හරියනවා. tomorrow past paper චුට්ටක් කරමු. Okay? What is gravitational field intensity? Now gravitational field intensity means gravitational field intensity මොනවද කියලා දන්නවද? Okay, give me a minute. Gravitational Okay. Gravitational field intensity. What is gravitational field intensity? Gravitational field intensity is the intensity at a point in a gravitational field. No, sorry. The force acting on a unit mass placed at a certain point. Force acting on a unit mass can then we have this F equals gmm over r square. That is for this equation. This diagram. Then අපි මෙතන we are making the mass of the other object, the smaller one, a known mass. මොකද 1 kilograms කරගන්නවා. That is the basic unit. Any mass, any what do you call object, any mass, m කියලා කියමුකෝ. If you have a mass m, if you divide it by simple m, you will get 1. 1 in 1 kilograms කියලා. Okay? So you are removing the aspect, you are forgetting the aspect of mass of the second object. හරිද? එතකොට to standardize that, we make it a unit mass. Unit mass කියන්නේ 1 kilogram තමයි unit mass කියන්නේ එක. Okay නේ? Then what do we do? By doing that, we can find the gravitational field intensity at a certain point. ඒ කියන්නේ මෙතන තියෙන mass එකට the mass at a certain point, the intensity of gravitational force you get for a mass at certain point. The intensity of gravitational force you get for a mass at a certain point is called gravitational field intensity. ඒර හරි meaning එක අපි ලියන්නේ, you can write it down right now. The force acting on a unit mass placed at a point in a gravitational field. The force acting on a unit mass placed at a point in a gravitational field. The force acting on a unit mass placed at a point in a gravitational field is known as gravitational field intensity. Okay, now හරි. එහෙමනම් how can we remove this mass? මේ mass එක unit mass කරන්නේ කොහොමද? We have F equals gmm over r square. හරිද? F equals gmm over r square. අපිට m එක මේ පැත්ත ගන්න පුළුවන් නේ. We can remove m. හරිද? By removing m, it gets standardized to 1 kilogram නේ. So F over m is equals to gmm over r square. Now for this F over m value, we give a symbol called simple g. Why do we give that symbol? If you check properly, either gravitational field intensity is also equals to gravitational acceleration. ඔන්න මෙතන ඉන්නේ අපිට ඉන්නේ මෙයා ඉන්නේ අපිට ඉන්නේ Newton kilogram per square meter කියලා. Newton kilogram per square meter කියලා දැන් මෙතන උත්තරේ එන්නේ. Newton කියන්නේ අපි let's say ml t minus 2 නේ. හරිද? මේක m square l minus 1 t minus 2 කියලා නෑ. no sorry. මෙතන Newton එකේ mass එක අඩු කරලා yeah. So here you are getting a certain acceleration නේ. Newton per kilogram කියන්නේ අපි kilogram නේ remove කරේ. Newton per kilogram කියන්නේ you are going to get a certain acceleration. Fortunately, they have figured out that this is also equals to a gravitational acceleration. එතකොට සාමාන්‍ය unit for gravitational field intensity is written as Newton per kilogram කියලා. Okay, Newton per kilogram කියලා තමයි unit එක දාන්නේ. However, Newton per kilogram is also equals to m is minus 2. You can use this to find gravitational acceleration as well. Okay. You can also find this in a different way, okay? අපිට කිරින්ම දාන්න පුළුවන්. හරිද? reaction force on the surface is equals to gravitational force කියලා. reaction force එක අපිට ලියන්න පුළුවන් mg කියලා. හරිද? gravitational force මේක ලියාගන්න below that. මේ මෙතන තියෙනවානේ. below we have written let force acting on a mass m by capital M be F equals gmmo r square කියලා තියෙනවා. like yeah below ලියලා තියෙනවා. ඒකට පල්ලේ ලියන්න reaction force is equals to gravitational force මේව ලියන්න. mg is equals to gmm over r square. අඩි m දෙක කැපෙනවා. then we are left with g is equals to gm over r square. Okay, this is the equation for gravitational acceleration. Gravitational acceleration එකට මේවයි gravitational field intensity කියලා තියෙනවා. Okay, you can also find gravitational field acceleration is equals to electric gravitational field intensity by using these equations as well. Do you have any doubts? Do you have any doubts? If we don't have any doubts, we can move on to questions. I don't think you have any doubts. So let's do a question. Can you do questions? අපි දැනට කරමු. One එක කරන්නකො. Do the first question. Just do the first question. I'll give you 6 minutes. I'll give you 6 minutes. Gravitation force 6.67. 6.67. Use it as 2 over 3. 2 over 3 times 10 to the power minus 11. And do the equations, okay? Then you don't have to struggle with 6.67. Just go work with 2 over 3. Okay? Work with 2 over 3. Let's just complete the theory. Let's understand the theory now. Do the first question only. Chat enable කරලා තියෙන්නේ. Chat open කරලා තියෙන්නේ. අමාරු නම් වේගය අඩුයි නම් if I am slow, if I am fast, if you don't understand chat එකට දාන්න. If you have any doubts also chat එකට දාන්න. මේකේ තියෙන්නේ whatever it is gravitation for gravitation field intensity and then we have vector addition. Okay, අර part 2 කැලේ 4 5 6 vector addition වලින් යන්නේ. फर्स्ट एक करके डिस्कस करूं. 3 minutes left. We have finished doing. Put D1 in the chat. D1 के लिए chat पे डाल दो. We have finished doing. Okay. Uh, capital M. No, those are two different masses. Okay. Capital M की एक mass है, simple M की तव mass है. Actually, capital M is the third particle of mass capital M. And the question is kept at find the gravitational field intensity of that point, means you have to just yeah, that is the mass of the third particle. Again, අපි තියෙන particles දෙකක් තියෙනවානේ. We have a 500 kilogram particle. Okay, that's not 500 kilogram, that's like 10 grams. We have a 500 kilogram particle. We have another 200 kilogram particle. Now, at a perpendicular distance of 3 meters, මේව තව particle එකක් තියෙනවා. මෙයාගේ mass එක capital M. මෙයාගේ mass එක capital M. ඔනේමත් ගන්න පුළුවන්. මේක අනිත් පැත්තට ගන්න පුළුවන්. ඕකේනේ? Okay, time's over. अभी प्रश्न करो. So, mm, two masses of mass 200 kilogram, 500 kilogram respectively is kept 8 meters apart from each other, measured from the distances are measured from the center of gravity. So, measure करला तीन. Number one, find the gravitational force acting on each other. Gravitational force. Gravitational force can killing me equation Gm over r square. For the equation, you will get 1 mark. But it's better to write. Gravitational acceleration, I say 2 over 3 times 10 to the power minus 11 kilo. Later with practice, we can use 6.67. Okay. Mass of the, one mass is 500, other mass is 200. Divided by r square, we have 8 square, which means 64. 8 square is 64. Now we can cancel off 32. That will give us 16. Or no, actually, we can keep this as 32 and we can make it 10. Make these to 10. Then we are left with 1 over 3 times 32 times 10 to the power minus, we have 1, 2, 3, 4, 5 zeros, minus 11 means 6, right? 10 to the power minus 6. This will give us a certain answer. What was the answer? Can everyone count it? If we use 6.67, we are getting direct answer with 6.67 partial Sinisa. We are getting 1.06 times 10 to the power minus 8 newtons. Newtons kila the end of one. We are getting 1.06 times 10 to the power minus 8. If we use 6.67, means 6 is nothing in the okay. If you wrote 1 times 10 to the power minus 8, that is also fine. Next. Second one. Gravitational field intensity at the midpoint. Gravitational field intensity at the midpoint. Gravitational field intensity at the midpoint is the midpoint. ඒකට අපි equation ලියන්නමයි තියෙන්නේ because you cannot find using this, okay? So we have tried Gm over r square. Our gravitational may constantly I may use it 2 times 10, 10 to the power minus 11. Mass is okay, at the center, we have a problem. Now, let's say we added a mass of 1 kilogram here. We are adding a mass of 1 kilogram here, okay? What is happening? We have a force to this side. මේ පැත්ත force එකකුත් තියෙනවා. මේ පැත්තට force එකකුත් තියෙනවා. එහෙම නේද? Now, what is gravitational field intensity? Force divided by mass. That means a vector divided by scalar. Does it turn into a scalar? No, it turns into a vector quantity. So actually gravitational field intensity is a vector quantity. So we have to do vector addition. So we මෙයාට බලන්න ලියමු. Okay. So 2 times 10 to the power minus 3 times 500 divided by r squared is 4 square. So that is towards this side. මේ පැත්තට. We can add a, now the other force, the second force is opposite to it, so minus. 2 over 3 times 10 to the power minus 11 times 200 divided by 4 square. This will give a value of g is equals to 2 over 3 times 10 to the power minus 11 times 300 divided by 16. 500 minus 200 is 300, right? 3 there, we can cut these two. We are left with 1.25. Actually, 0.125 times 10 to the power minus 9. We can write this as 1.25 times 10 to the power minus 10 as well. This is our final answer. Newtons per kilogram. Don't forget the units. Okay, next. Don't forget the units. Newton per kilogram. Next, if a 200 kilogram mass is free to move, find the acceleration of the mass and direction. From this, I'm gonna take if equals ME. 1.06 times 10 to the power minus 8 is equals to 200 A. Acceleration is equals to 1.06 divided by 2 times 10 to the power minus 10. Acceleration is equal to something like 5.3 times 10 to the power minus 11 meters per second. Meters per square second. Okay, next. That is our acceleration. Now we are keeping third particle. We are keeping a third particle at 3 meter distance from the midpoint of the line joining the two masses. Then we have to find the hypotenuse, right? අපි x equals gm over r square දාලා force එක මෙහෙම calculate කරනකොට we have to use r square such that the two center of gravities are connected. So මෙයා 4 මෙයා 3 නම් hypotenuse එක 5. එහෙම කියලා theory එක නෙමෙයි පොඩි shortcut එකක් තියෙනවා. We can use that නේ. Also we can write this angle is theta. If this angle is theta, we can say cos theta is equals to 3 over 5 and sin theta is equals to 4 over 5. Let's keep this in mind and do the rest of the question. Okay, ne? Second part. Actually, no, we continue the numbering. Fourth one. Find the gravitational field intensity of that point. Yes, gravitational field intensity. Peter, same angle here, okay? Same angle here. We can write in this question, you can first of all find the force and then divide by the mass also, okay? We can find the force and divide by the mass as well. Find the force again. Let's take Hari. Horizontal forces වලට මොකක්ද වෙන්නේ කියලා පොඩි ප්‍රශ්නයක් එනවා නේද? හරි මේකට වැඩි වෙලාවක් යනවා. It's okay, 6 minutes is not enough. If you couldn't do it, it's fine, okay? අපි පළවෙනිට ලියමු vertical forces. The vertical forces, if vertical is equals to g m g කියන්නේ 2 over 3 times 10 to the power minus 11 times m කියන්නේ 200 simple m අපිට දාන්න divided by 5 square. Make it cos theta times cos theta plus 2 over 3 times 10 to the power minus 11 times 500 times m times cos theta divided by 5 square. අපිට එනවා F is equals to what is cos theta again? 3/5 නේ. Cos theta is 3/5. 3/5, 3/5. We can cancel this 5 off. මෙතන cancel කරන්න විදියක් නැහැ. We can cancel this out. So 20, yeah, 20 with 5. We can cancel 3. 3 එක ඔක්කොම cancel වෙනවා. 5 squared කියලා තියෙන්නේ. 5 squared කියන්නේ 25. අපි 5 එකක් අපමු. You will get 8 here. Here, actually, you can cut 25. Then you will get 4 here. අපිට එනවා 16. 16 divided by 5 is? What is 16 divided by 5? 3.2. So 3.2 times 10 to the power minus 11 plus මෙතන 8 තියෙන්නේ. 8 times 10 to the power minus 11. The total addition එකක් එනවා 8, 9, 10, 11.2 times 10 to the power minus 11 newtons. කොයි පැත්තටද? Vertically. Vertically හොයාගත්තා. Now horizontal forces හොයන්න ඕනේ. Horizontal forces what will happen? Horizontal forces අපිට එනවා, I'll erase this part. Horizontal forces is equals to, let's take to the 500 side. Yeah. 2/3 times 10 to the power minus 11 is G. Mass is 500. We don't know the unknown mass. Actually, this is upper G. හරිද? upper G එකක් තමයි ඉතින් තියෙන්නේ. 500 times M sin theta කියන්නේ 4/5 divided by 5 square. Minus 2/3 times 10 to the power minus 11 times 200 times M times 4/5 divided by 5 square. This will give us a result 2/3 times 10 to the power minus 11 times 300 times 4/5 divided by 5 square. 3 කැපෙනවා. අවුලක් නැහැනේ. We actually will get a 5 cube. කරන්න දෙයක් නැහැ. There's one way to solve it. This is 100 නේ. We can cut this off to get 4. Then we have 4, 4, 16. 16 times 2, 32. 32 divided by 5 times 10 to the power minus 11, which is equals to 32 divided by 5 නේද? 32 divided by 5. 6.4 times 10 to the power minus 11 newtons. හරිද? Actually newton per kilogram. හරිද? ඊට පස්සේ vector addition දාලා ඒ දෙක manage කරන්න තමයි තියෙන්නේ. P squared plus Q squared cos theta ඒවත් පාදලා හදන්න. If not, this is enough. Because you know, after this is going to be vectors. If they ask to directly simplify after that, you can continue the question. Next one. If D equals 3 meters, find the gravitational field intensity at that point. හරි 3 දාලානේ හරිනේ. 3 දාලා තමයි එන්නේ. Otherwise it's going to be F equals gmm r square. හරියටද? fourth one එකට F equals g m 500 over r square minus g 200 over r square. ඊට පස්සේ r square දැන්නේ දුන්නේ ඊට පස්සේ ඒකට 5 square ඔක්කොම දාලා උත්තරේ ගන්න ඕනේ. Next they are asking for the force. We can get a horizontal force using this, vertical force using this, and calculate the final answer. Now like nan shape ni. Do you have any doubts? I don't think so. No, right? Thumbs up එකක් දාන්න බලන්න if you don't have any doubts. If you have any doubts, put a thumbs up. No, sorry. If you have any doubts, then give it. If you don't have any doubts, put a thumbs up. Doubts තියෙනවද? නෝනේ? Okay. තව පොඩි question එකක් කරලා දාමු. Hmm, let's do 6 and 7. 6 and 7. 6 එක කරන්න බලමු. Three particles each of mass simple limb is placed on a vertices of an equilateral triangle of side length A. ඒක චුට්ටක් පොඩි උදව්වක් දෙන්න. The gravitational field intensity at the centroid of the triangle is. අපිට triangle එකක් තියෙනවා 6th question එකට අපිට triangle එකක් තියෙනවා. මේ triangle එකේ වටේ අපි main mass එකක් දීලා තියෙනවා. හරිද? Now they are asking for the gravitational field intensity at the centroid. හරිද? We can say number 1 forces act on the main direction එකේ, so you have to find this මේ ඒව හොයන්න ඕනේ නැද්ද කියලා ඔයා හිතා ගන්න ඕනේ anyhow. The forces are acting along this axis. Now find the answer and put it in the chat එකේ දාන්න බං. What is the answer for the 6th question? Do you have any doubts? So doubts නෙමෙයි. මේ උත්තර දෙන්න පුළුවන් 6th එකට. Simple. Don't have to go through a lot to figure it out. If you think about it. Okay. It is a දැන් මම කියලා ගන්න. එච්චර ලොකු වෙලාවක් ගන්න. You might be doing a lot of questions. What do you call? Calculations. මෙතන කතාව first answer තමයි උත්තරේ. The force is 0. ඒ කියන්නේ force is equals to 0. What is the reason? Gravitational field intensity. අපිට මේම force එකක් තියෙනවා, මේම force එකක් තියෙනවා, මේම force එකක් තියෙනවා. All three forces are of the same magnitude. Then what will happen? මෙයාගේ what do you call components will get cancelled off with components of this one and components of this one. So ඔක්කොම cancel වෙලා you are ending up with 0 as our gravitational field intensity. Okay නේ? වෙට් ඇඩිෂන් යන්නේ. මෙයාගේ මේම cos 60 දැම්මම මේ දෙන්න cancel වෙනවා. මෙයාගේ cos 60 දැම්මම cancel වෙනවා. Okay නේ? Seventh question එක කරන්න බලමු. Seventh එක. Yeah, do the seventh one. Seventh one එකක් කරමු. Seventh one. Okay, let's do the seventh one. We have given mass of a body, aka W. W is equals to GMM over R square because why? This is the body of weight W meters in the surface of the earth, where is W over 9 at a distance, certain R distance from the earth's surface. Even an R name, mass 6400 square. Okay, W over 9 can name GMM over R square. Only now what can we do? What can we do? We are dividing these two. When we divide, what do we get? When we divide W දෙක කැපෙනවා GMM ඔක්කොම කැපෙනවා we get 9 over 1 is equals to R square over 6400 square. On the square within ගන්න නම් අමාරුයි, therefore we are removing the square. The 3 1 and 3 times 6400 කෙලින්ම cross multiply කරන්න පුළුවන් is equals to R. R is equals to 3 times 4 is 12. Yeah, 1 left. 6 times 3 is 19. No, wait. Okay, it's not 3. Is it? Yes. Yeah. And 192,000 kilometers. Is that the answer? No, that is not the answer. They are asking, okay, this is not the answer because this is wrong. We have to actually calculate simple R square. Why? They said R is the distance from the Earth's surface. Again, Earth's surface is the distance R. We calculated the distance from the center of gravity to the object. So make අඩු කරන්න ඕනේ නේද? So we have to reduce 6,400 kilometers from this. That means our final answer is capital R is equals to 12,800. Even 12,800 kilometers. That is our final answer. අනිත් homework දෙන්න වෙලාව තිබ්බනම් we'll do. Okay. 8, 9. Actually 8, 9 නෙවෙයි. 8 to 8 to 8 to 18. These 10 questions. Homework දෙන්න කරලා ඉන්න. Okay. 8 to 18. Next. Now let's go to next theory. එහම චුට්ටි චුට්ටි theory කරලා පුළුවන් නම් අද ඉවර කරමු. We have time till 6 නේ. Now it is 3. Yeah, we might be able to finish the theory today itself. Okay. Yeah. And then tomorrow මේ දාන homework ඔක්කොම කරලා okay නේ? Homework ඔක්කොම කරලා past papers ඔක්කොම කරලා yeah, tomorrow will be a really good session. Okay. Variation of gravitational field intensity with simple R. Now, what is the equation for gravitational field intensity? F equals GMM over R square. That is our equation. But there's a condition for this equation. As condition for this equation, if we take an object and that object has a radius of simple capital R, for this equation to apply, simple R should be greater than capital R. නැත්නම් මේක හරියන්නේ නැහැ. මේ equation එක කරන්න බෑ. Okay නේ? මේ equation එක මේ equation එක පාවිච්චි කරන්න බෑ. So what is our proportionality? F is proportional to 1 over R square නේ. F is proportional to 1 over R square. On the side එක ලියාගන්න F is proportional to 1 over R square කියලා. 1 over R square කියලා ලියලා F is proportional to 1 over R square. Yeah, F is proportional to 1 over R square. Therefore, 1 over R square, y equals 1 over x square graph එක කොහොමද ඉන්නේ? ඔන්න ඔය වගේ එකක් තමයි ඉන්නේ. Draw this graph. මේ වගේ එකක් තමයි y equals 1 over x square graph එකක් ඉන්නේ. This is force. So this is gravitational acceleration, gravitational field intensity, and this is radius. Okay. F එක F කියලා ලියන්න බෑ, මෙතන G කියලා ලියන්න. අපි G ගැන කතා කරන්නේ gravitational field intensity ගැන. So gm over r square ඔන්න r එක තමයි equation. This is how you get the graph. After a radius of capital R. Now there's another problem. There's another problem. Actually මොකද්ද වෙන්නේ? What will happen inside? මෙතන මොකද්ද වෙන්නේ? කියලා ප්‍රශ්නයක් එනවා නේද? එහෙම ප්‍රශ්න for that we have to derive another equation. ඒ derive කරන විදිය බලාගෙන I'll give you time. Okay? Write it down. First of all, look at it. Okay? First of all, look at it. අපිට කියන්න පුළුවන් mass is equals to volume times density. What is volume? 4 over 3 pi r cube bro. Therefore we can say mass is proportional to r cube කියලා. අපිට density වැඩක් නැහැ, pi 4 over 3 වැඩක් නැහැ. Mass is proportional to cube of the radius. Okay. Now we can write හරි. මෙහෙමනේ ස්පීඩ් එක තියෙන්නේ. This is our planet. Okay, what we are going to do is we are going to find the mass of the internal sphere. හරිද? ඒ කියන්නේ මෙයාගේ radius එක r, මෙයාගේ radius එක r නම් හරි මේ ඇතුලේ තියෙන එකනාගේ mass එක තමයි හොයන්න හදන්නේ. Okay නේ? Then we can write simple m over capital M is equals to simple r cube over capital R cube. Okay නේ? එහෙම ලියන්න පුළුවන්. This we can subject simple m. Simple m නෙමෙයි. Yeah, we can subject simple m. We can subject simple m, and by subjecting simple m, we'll get simple m is equals to capital M R cube divided by capital R cube. Okay, make it now. Now, what did we say? Gravitational field intensity is equals to gm over r square. R square. ඔන්න මෙයාව මෙතන substitute කරනවා. Substitute කරනකොට we'll get g m r cube divided by r square times r cube. Okay නේ? මේ දෙන්න කැපෙනවා. We are left with gravitational field intensity is equals to gmr divided by capital R cube. Now g is proportional to simple r. Simple r කියන්නේ මොකක්ද? Radius of the internal circle. Okay, by the way, this is gravitational field intensity when our radius is less than the radius of the planet. Okay. On aim කරගෙන යනකොට we get g is proportional to r equation එකක්. G is proportional to r equation එකක්. මේ කෙලින් අපිට ලියන්න බෑ y equals mh graph එකක් වගේ කියලා ලියන්න පුළුවන්. y equals mh graph එකක් වගේනේ. Then how do you get the graph for this? ඔන්න මෙයාට තියෙන graph එක The graph for this will be make a sphere now y equals mx form. Y equals mx form, but the highest points connect to this point. Okay, the highest point both the highest points make with this is how we get the variation of gravitational field intensity when the radius is lower than the radius of the sphere. Radius is lower than the radius of the sphere. හරි. දැන් මේ graph එක තියෙනවා මේ graph එක තියෙනවා both the graphs are same. So we'll merge them. හරිද? merge කරනකොට what do we get? We have a circle, actually we have a planet. හරිද? and then අර planet එකේ center එකේ ඉඳලා අපි radius එක ගන්නවා. This radius is r. This is gravitational field intensity. Okay නේ? This is the graph we have. හරිද? රතු පාටෙන්, I mean when the radius is lower than the radius of the sphere, we get a y equals mx graph. හරිද? When the radius is greater than the radius of the sphere, මෙතනින් පටන් අරගෙන, okay, at this point we have to start at this point and මේම continue කරනවා. Okay, ඔන්න මේ වගේ graph එකක් එනවා. හරි. graphs තුනම and now you can write down this, draw this graph and write down this note. note එක ලියන්න එච්චර ඉඩක් නැහැ. On either side of the graph, for the second one, variation of gravitational field intensity when the simple r is less කියන තැන, beside the two graphs, write this note. ලිව්වට පස්සේ D2 කියලා message එකක් දාන්න. Then I can go to the next theory. මේක මේකට වඩා පොඩ්ඩක් වෙනස්. I hope you have finished writing. I hope you have finished writing. Now let's go to the next theory. Next theory අපි note එකමු මොකක්ද? Gravitational potential. Okay, that is a nice story. ඒකෙන් තමයි අපිට දැන් තව වැඩක් ඉන්නේ. What is gravitational potential? Up to now, we have a large mass of capital M. We have a smaller mass of simple M, or 1 kilogram, if it was unit mass. And then we only talked about the direction of forces. We didn't move this kind of man. It's just staying there. We're just talking about forces between them. We are just talking about forces between them. Now we are going to talk about the change of energy, work done and all due to the motion. Now there's a force on this. Force force because of this force, this object will start to accelerate. And due to this acceleration, there will be certain distance traveled by this object. Okay, that means F කියලා එකෙනෙක් ඉන්නවා D කියලා එකෙනෙක් ඉන්නවා. That means there is a work done on this object. Okay, there will be work done on this object. Now this work done. මෙයාව තමයි අපි calculate කරන්න යන්නේ using gravitational potential and gravitational potential energy. What is gravitational potential? Gravitational potential is the work done in bringing a unit mass from infinity to a position to a point in the gravitational field. Make it when a කතාවක් වෙනවා. What is infinity? At a certain point for this mass, the force of this mass will become negligible. මෙතන වගේ infinity වෙනවා. මෙතන force එකක් නැහැ. Force is zero. අන්න අර වගේ තැනක ඉඳලා from a place somewhere like this to bring a unit mass into the gravitational field, you have to do a certain amount of work. Now that work is known as gravitational potential. The gravitational potential එකට what are the units? What are the units for gravitational potential? Joules per kilogram. Why? This is for unit. Unit mass. Unit mass is 1 kilogram mass. So joules per kilogram. This is the unit of gravitational potential. Unit of gravitational potential symbol is V. Unit is joules per kilogram. Equation is minus Gm over R. How did we get this equation? Per unit mass की gravitational field intensity equation for gravitational field intensity Gmm over R square. Like make it work without we have to multiply by the distance it has traveled. Okay, distance that it has traveled will be actually infinity minus R. Other infinity up to උත්තරයක් දෙන්න බෑනේ. Then මෙයා 0 වෙනවා. මෙයා 0 කරගන්න පුළුවන්. නැත්නම් මෙයා infinite කරගන්න පුළුවන්. ඊට පස්සේ ආයි ඉතුරු වෙලා තියෙන්නේ minus gm over r. This is how you get the minus, and that is why the gravitational potential is always negative. Gravitational potential is always negative. Dimensions of gravitational potential. L2 t minus 3. Okay, L2 t minus 3 is the what do you call it? Gravitational potential. මේක පොටෙන්ෂල් එක තමයි L to T minus 3 කියන එක. නෑ so unit මේ dimensions ටික. දැන් මේ තව අවුරුද්දකට කරගෙන ඉන්නේ units and dimensions කරන්නේ. ඕනෑ වරන් ජූල්ස් එකට ලියලා ඊට පස්සේ ඒකෙන් කිලෝග්‍රෑම් එක අයින් කරන්න. mass එක අයින් කරන්න. then you will get this units. Next. Note. Okay, note. අර note එක මම explain කරන්න. Why? Okay, this is the calculation or theoretical concept. I minus in එකට කියලා. There should be another explanation as well, and there like a practical explanation. Now, what are you trying to find here? Work per unit mass. Work per unit mass. ඔන්න මෙතන අපි mass එක තිබ්බනම් 1 kilogram mass එක තිබ්බනම් what will this guy try to do? මේ mass එක අරයව අදින්න බලනවා. It will try to pull the mass inside. Till work is done. Work is done. Work is done by the mass. ඇයි මේ දෙන්නට ආසේ ලඟ වෙන්න ඒ නිසා එයාම may that mass is on its own coming towards this mass. So අපි energy එකක් දෙන්න ඕනේ. So work is done by the mass itself. ඕනේ නම් එයා energy release කරනවා. හරි. මේ එනකොට මෙයා energy release කරලා දානවා. හරි. That's why it is a negative potential. හරිද? Happy, if you want to push it apart, if you want to bring it from here to here, what should we do? We have to give a certain amount of force and push it away from the mass. So work is done by me. Or work is done on the what do you call? Yeah, work is done on the mass. So they are positive වෙනවා. ඇයි මේ තල්ලු කරනකොට positive වෙනවා. When it is coming on its own to the mass to a gravitational potential, it becomes negative. That's why we get negative sign here. Okay, මෙයා මකලා දාන්න. Okay. හරි, variation of gravitational potential with R. Simple. හරි. මේ ස්පියර් එක තියෙනවා. Okay නේ? මේව කට් එකක අදිනවා. අපේ equation එක මොකද්ද? V is proportional to 1 over R. Actually, minus 1 over R. මේ minus sign එක නිසා මෙයා minus එකේ graph එක එනවා. Like අර උඩ graph එක minus වලින් multiply කරනවා. What will happen then? මෙයා මෙතෙන් තියෙන එක මෙතෙන්ට එනවා. ඇයි මෙයා minus region එක. එහෙනම් minus region එකේ same graph අදින්න ඕනේ. Minus region එකේ same graph අදින්න ඕනේ. This is for potential versus මේක. Can you find a value inside the sphere? අප්පෝ නෑ මේකට බෑ. අරකට විතරයි special case. Within the sphere you can find gravitational wave intensity. Gravitational potential එකක් නම් හොයන්න බෑ. Okay නේද? Gravitational potential එකක් හොයන්න බෑ. And then we have another point. What is the other point? මේ graph එක ඇඳගන්න මේකත් ලියා ගන්නකෝ. graph එකත් ඇදගෙන මෙයාවත් ලියා ගන්න. Gravitational potential meaning එක ලියා ගත්තා නේද? ලියා ගත්තා කියලා මම හිතනවා. මට මතක නැහැ. ලිව්වද කියලා දන්නේ. What is gravitational potential? The work done in bringing a unit mass. Work done in bringing a unit mass from infinity to a point in gravitational field. Work done in bringing a unit mass from infinity to a point in gravitational field. ඔන්න මේ පින්තූරයෙන්ම මතක තියාගන්න. හරි ඉන්ෆිනිටි එකේ පොඩි කෙනෙක් ඉන්නවා. එයාට ඒ පොඩි කෙනාව අරන් එනවා. මේ ග්‍රැවිටේෂන් ෆීල්ඩ් ඇතුළට. So the work done to bring that guy inside the door, or inside a crowded space, is known as gravitational wave or gravitational potential. ඊට පස්සේ මෙයාව ලියාගන්න මෙයාවත් ලියාගන්න. After writing that, put D3. D3 කියලා ලියන්නකො. D3 කියන කෙනෙක් ලියන්න. මේ ටිකත් ලියාගන්න. Okay. මේ ටිකත් අර specific places ටික මේක unit, මේක dimension, මේක equation එක. D3 කියලා දාන්න ඉවර වෙලා. Finish it and write D3. ඉවර කරලා දාන්න D3 කියලා. D3. හරිනේ? කොතනද? හරි. done. Now we have to find the gravitational potential difference between 2 points. 2 points කියන මොකක්ද? We have a certain sphere. ඔන්න මෙතන A කියලා එක්කෙනෙක් ඉන්නවා, මෙතන B කියලා එක්කෙනෙක් ඉන්නවා. We have to find the potential difference between these 2 points. අර battery එකේ potential difference කතා කරන්නේ මේ similar to that. So we can write VA is equals to minus GM over මෙයාට කියමු R1 මෙයාට කියමු R2 කියලා. GM over R1. VB is equals to minus GM over R2. When the potential difference of B relative to A can be written as minus GM. හරිද? GM 1 over R2 minus 1 over R1. ලියන්න පුළුවන් නේද? එහෙම ලියන්න පුළුවන්. So you're going to minus GM initial radius minus final radius. A කියන්නේ okay, so that is the potential difference. Okay, potential difference. That is our potential difference. ඔව් ලියාගන්න. මේක තමයි අපේ potential difference එක. ලියලා D4 කියලා දාන්නකො. ඊට පස්සේ තමයි අපිට ලොකු වැඩ එන්නේ D4 කියලා දාන්න. After D5 we can do some questions and take a break. අතරට break එකක් දෙනවා. පොඩි break එකක්. හරි. D4. Gravitational potential energy of a mass in a gravitational field. Gravitational potential energy of a mass in a gravitational field. ඒකෙන් මොකක්ද? Write it down. Write it down. The amount of work done in 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 bringing a body from bringing a body from the amount of work done in bringing a body from infinity to a point in a gravitational field. Bringing a body from infinity to a point in gravitational field. Infinity to a point in gravitational field. Okay, amount of work done in bringing a body from infinity to a point in gravitational field. ඔන්න මේකට වෙනස මොකක්ද කියලා අහන්න හිතෙනවානේ. Now we use unit mass. Okay, මෙතන simple m එකක් add වෙනවා. Mass of the object also gets added. හරිද? එතකොට අපිට කෙලින් වෙනවා ඒකට පල්ලෙහා ලියන්න energy gravitational potential energy is equals to gmm divided by r. මෙයා capital M simple m divided by r. R squared නෙමෙයි simple r. now minus that's minus same story that's minus units දන්නවනේ energy units දන්නවා gravitational potential energy ගේ dimensions දන්නවනේ ඒක එම්ම ලියා ගන්න හරිද ඒ units ඒක ඔයාලගේ වැඩක් ඒක ලියා ගන්න එතන ඔන්න now that is the story after writing that let's do some questions okay d5 කියලා දාන්නකො d5 කියලා දාන්න we'll do some questions and then we'll go to the next part ඒකේ පල්ලෙය කැලලට යමු ඒක පල්ලෙය ලොකු ස්පේස් එකක් තියෙන ඒක ලොකු explanation එක ලියන්න ඕනේ නිසා okay d5 කියලා ලියලා දාන්න after you have done this d5 yes mm, hmm, d5 d5 no let's do 19 19 20 bag 19 20 bag 19 විතරක් කරන්නකො 19 විතරක් කරන්න අනිත් ඒවා වලට බෑ 19 විතරක් කරන්න I asked you to do 19 නේ. ඒක කරන්ඩ I forgot. That is හරි. For that the answer is 3. What is the reason? What is the reason? Third answer in the reason මොකක්ද? Simple. We have two masses. The two masses are connected to each other. No, actually there's a line connecting each other. They are asking for gravitational potential at midpoint. Gravitational potential due to this mass, actually, gravitational potential due to, actually, not even the third answer. I guess it is the first answer. Because the gravitational potential energy due to this point, gravitational potential due to this point will be Gm over R over 2. Okay. Due to this mass, it will be 2Gm over R as well. Now, energy is a scalar. And potential is also a scale. මෙතන අපිට තියෙන්නේ add වෙන එකකින්. We are adding these two. So actually here it is going to be 4Gm over R. Okay. This is going to be 4Gm over R. That's the third answer. Is going to be the fourth answer. Okay. Yes, that is going to be our fourth answer. Minus 400 G over R කියන එක උත්තරේ. Next. හරි. ඒක විතරේ දැනට කරන්න පුළුවන්. Okay, I'll give you another question from the earlier question. Um, mm, 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 mm. Mm-hmm. 10th question එක කරන්න බලමු. මෙතෙන් 10th මේ 10th question එක කරන්නකො. 10th question එක කරන්න. ඒක homework නෑ. ඒ 10th question එක දැන්ම කරන්න. Tenth question එක කරන්න. Do the 10th question. 10th question එක කරන්න. Okay. Now let's see that make question. Gravitational potential energy. Mm-hmm. 10th question. 10th question. A rocket is fired from Earth to the moon. The distance between the center of gravity of the Earth and the moon is simple r. The Earth and the moon is simple r. And the mass of the Earth is 81 times the mass of the moon. Gravitational force on the rocket will be zero when its distance from the moon is. Hurry. We have two, Earth and the moon. Mag mass M nang mag mass 81 m. The distance from the center of the center of gravity is given by question hari r abhi r kira dheere denge so no problem hello r kira dheere denge so no problem. They are saying at a certain point, let's call that point x from the earth, right? Asking from the, oh, they are asking from the moon. So we'll take distance from the moon as x. At a distance from the moon x, the forces balances out. Force टिके cancel වෙනවා. have මේ දෙක force ටික balance වෙනවා. Then we can write an equation to that point. F equals gmm over r square. This is our equation. Gmm over r square. For the first one, we can write force by the earth is equals to force by the moon. What is force by the earth? G 81 m divided by r minus x. The r minus x squared. And moon is going to be gmm divided by h square. ඔන්න මේ m කියන එක නම් වෙන විදිහට ලියාගමු. If not, we'll get confused. We can cancel some things off. gmm cancels off. We have 81 h squared is equals to r minus h square. R minus h square. Square root everything, we can get 9x is equals to r minus x. R is equals to 10x. X is equals to r divided by 10. So this value is r divided by 10. On r divided by 10 කියලා උත්තරයක් තියෙනවද? Yes, we have we have r divided by 10. That is the third answer. So third answer is our answer for the question. Alright. Now, මේ theory එකම පාවිච්චි කරලා use the same theory, okay, same method and an additional method to find gravitational potential. Do the 20th question. On the 20th question, may දැනුව නැතර without knowing the method for this, you cannot do the 20th question. ඒක නිසා තමයි 10th එක කරේ. Do the 20th question now. Yeah, recordings available. Recordings available. Okay, so where are we? Yes, we have to do the 20th question. Yeah, 20th question. Hurry. They're asking you to find the gravitational potential, right? Gravitational potential at a point joining the two of them. We have masses m and 4m. Okay, we have m and 4m and distance capital R. No, simple R. Okay, we have 4m, we have m. Make gravitational field acceleration is 0. This distance is capital R, not capital R, simple R. Then we have to find the point where, we have to find x. I don't need to write that. I'm just writing here G 4m, 4m, capital M divided by R squared. Actually, this is gravitational field intensity, so no need. Is equals to Gm divided by R. Actually, this is R minus h squared and R squared. We are simply getting 4R squared is equals to R minus h squared. 2R is equals to R minus x. මොකක් හරි කැත කරලා දැම්මනේ. මෙයා මොකක් හරි කැත කරලා දැම්මනේ. මේ R squared මේ h squared මෙයාත් h squared මෙයාත් h squared මෙයා x. So අපිට එනවා 3x is equals to R කියලා. X is equals to R over 3. Now we are going to find the gravitational potential at this point due to each masses. Due to 4m mass. V is equals to minus G 4m divided by 2R times 3. We are getting minus 6m over 6gm over. Okay, the minus 6gm over. We are left with minus 6gm over. Due to m mass, we get minus gm, 3gm divided by R. R over 3 name, so 3gm divided by R. So what is the total? Total again minus 9gm over R. Minus 9gm over R is our fourth answer. Fourth answer is minus is the answer for the 20th question. ඔන්න එහෙම තමයි සමාන ප්‍රශ්න හදන්නේ. Okay. Now let's go to the other theory. Other theory එක ඉවර කරාට පස්සේ we'll take a small 10 minutes break. Okay. We'll take a small 10-minute break. Now, एक हदान we need a lot of space. Now, using this, what can we get? Difference in the work done is equals to minus gmm 1 over 1 minus 1 over 2 කියලානේ. This is nowhere equals to gmh. Actually, this is nowhere equals to mgh. There is no way equals to mgh නේ. අපිට දන්න what is g කියලානේ. g කියන්නේ මොකද්ද? gm over r තමයි mgh. gm over r කියන එක තමයි mgh. ඔන්න එයාව substitute කරත් මෙතන mgh කියලා එක්කෙනෙක් එන්නේ නැහැ. We don't get mgh. mgh is in there. Then what can we do? We are going to prove that this has it's actually valid for mgh කියලා. මේකෙන් තමයි mgh ආවේ කියලා derive කරන්න යන්නේ. mgh කියන equation the gravitational potential energy. What is gravitational potential energy? mgh. mgh ආවේ මෙතනින් තමයි කියලා අපි we are going to find it out. හරිද? You might need both sides or one side depends. Okay. First of all, we have to draw earth. Earth එක නිකන් ඇදගන්න. From the center the radius is r. And then we are talking about a small height h. We are talking small height h, okay? It is lower than r. Actually, extremely lower than r. Okay? We are not talking about h is equals to r or greater than r. Okay? In that case, okay, we have to draw this diagram and write this as well. In that case, gravitational potential energy at P. Gravitational potential energy at P. What is gravitation? මෙයා P කියලා ගමු. මෙයා P, මෙයා Q. The gravitational potential at P is equals to minus gmm divided by r. The gravitational potential energy at Q minus gmm r plus h. Now we are going to find the energy difference. එතකොට gravitational potential energy difference is equals to Q minus R. Q minus P. Q actually P minus Q. Because Q is a low value. Okay. P කියන එක කවද minus gmm divided by R. හරිද? මෙතන ඉන්නේ මොකද්ද? plus එකක්. Because minus minus plus නේ. gmm R plus H. Okay, gmm R plus H. Common multiple එකක් ගන්නවා. We are taking a common multiple. What is the common multiple going to be? R plus H. R plus H. Again, gmm common. gmm common නේ. gmm common. අපිට එනවා R plus H minus R කියලා. පිළිගන්නවද? ඒකෙන් R plus H minus R. මේ R දෙක කැපුවම we are left with changing gravitational potential energy is equals to gmm H divided by R plus H. But we have some, okay. I'm going to take R out. Within තව R එකක් එළියට ගන්නවා. We are going to take another R out. If we take another R out, we'll get gmm H divided by R squared 1 plus H over R. We know gravitational potential energy, not gravitational field intensity or gravitational acceleration is equals to gm divided by R squared කියලා. Okay, gm divided by R squared is equals to මොකක්ද gravitational acceleration කියලා දන්නවා. එයාම මෙතන substitute කරනවා. Then difference in gravitational potential energy is equals to mgh 1 plus h over r. Now this point we wrote here is going to work here. As h is really, really small to r, the h over r will be something like 0.01. We can say directly say H is almost equals to 0 කියලා. HOR. If HOR is almost equals to 0, this whole equation will go to 1. දැන් ඔන්න අපිට කෙනෙක් වෙනවා difference in gravitational potential energy is equals to mgh. ඔන්න ඒ මේම තමයි we are using the equation mgh in what do you call mechanics. Mechanics වල difference in gravitational potential energy කෙනින්ම mgh ගන්න මේක නිසා. If you want to explain this more, we can say h is somewhere closer to actually h is somewhere in between. We normally take h in between 10 and 1000 meters, නේ? 10 and 1 kilometer. But R is equals to 6,400 kilometers. On the 1 day 6,400 running bidwama, you will end up with absolutely nothing. 0.0001 කියලා තමයි. That's why we can directly cancel this off to 0, so the total addition goes to 1. Okay නේ? මේක ලියාගන්න. Now it is 3:58. මේක ලියාගන්න take a break for 4:10 hari 4:15 hari ආයෙ පටන් ගමු. Okay? Okay. Breaks over. Let's start the session. Hope everyone is there. If everyone is there, put a thumbs up. Thumbs up ഒക്കെ ഇതാണ് പറഞ്ഞു. കോശിയായിരിക്കില്ല അത്. No, ne? With that, I'm also gonna give you homework. Okay. So homework is gonna be we have to do up to 18 for now. 19 we did. 20 we did. 21 to okay 20. 21, 22. Okay, 21, 22. Next, what do we have next? Um, Now we are going to talk about satellite motion. Now, mainly in our syllabus. Now, that's all the gravitational force related equations. Now you have to apply those equations. Normally, you apply them to a planet versus moon system, planet versus satellite system, sun versus planet system, or sun versus asteroid dwarf planet system. Also, I guess I can remember once there was a black hole versus sun, black hole versus stars, black hole versus stars. Our sun is part of a universe called Milky Way universe. Milky Way की मदद है black hole. So black hole with the sun, it will give you a certain what do you call? Motion, gravitational motion. Yeah, 18, So using those, we can do. Yeah, we can. We have to know to how to apply equation for them correctly. The best way is to learning how to apply it for satellite because satellite has so many other stuff compared to the other systems. அது திரும்பியாக போடுவாங்க satellite motion போடுவாங்க அனைத்துக்கும் போடுவோம். If a satellite of mass, right? If a satellite of mass m, a satellite of mass m moving in a circular orbit r, speed v, planet of mass m, centripetal acceleration and gravitational acceleration would be Mukad. Centripetal acceleration is actually from the mechanics lesson. Centripetal acceleration will be mv squared over r. Centripetal acceleration. Gravitational acceleration will be actually force will be gmm over r squared. Okay, gmm over r squared. Now we have to Mukad Kandrin. We have to equate it. Actually, centripetal acceleration doesn't have m, okay? Just v squared over r. Now we have to equate it. I will end up f equals ma. Are the force name acceleration, centripetal acceleration. Force is gmm divided by r squared. Mass is m. Centripetal acceleration will be v squared over r. Now we can cancel off. What can we cancel off? M gets cancelled off. M gets cancelled off. R also gets cancelled off a bit. And we are left with v squared is equals to gm over r. We can write this as v equals root gm over r. Okay, this is the equation for velocity of a satellite orbiting in a certain radius of with around a planet of mass capital M. We are still not finished. අපිට තව එකක් කියන්න what is g equals to gmm over r square. ඔන්න මේ R එකක් මෙතනට දානවා. RG කරනවා. Okay. RG කරාම we are left with GM over R. හරිද? GM over R. So we can put this here. මෙයා මෙතෙන්ට දැන් මම එන්නේ velocity is equals to, actually this is tangential velocity, okay? Tangential velocity is equals to GR, root GR. Tangential velocity is equals to root GR. Okay නේ? හරි. So that is how you can get, velocity of not velocity, no, what velocity do you call it? Tangential velocity of a satellite. Tangential velocity of a satellite මෙහෙම තමයි. If you actually want to find angular velocity, v equals r omega, divide this entire thing by r. Then you will get the something like omega is equals to uh, g over r කියලා. This will be our angular velocity. ඔන්න ඕනේ නම් එයාව තියාගන්න. I don't know how much space did I leave. Yeah, according to Newton's second law of motion, you are going to write all this. Okay? You are going to write all this. All this and all this and up to this. Make වෙනකන් ලියනවා. ලියලා it says if G is the gravitational field intensity, G is the gravitational field intensity. ඒතකොට මෙතනින් this part you are writing it after then. Okay නේ? then කියලා කැරක් තියෙන then comma කියලා. ඒකට පස්සේ දැන් මේකයි ලියන්නේ. Okay නේ? This part you are going to write under the space given under according to Newton's law of motion. ලියලා D ඔය ෆයින් එකේ D6 කියලා දාන්න. ලියලා write D6. If you have finished writing D5, D6 కి దాన్ని నెత్తమంటది వెంటనే. దాన్ని ඔක්කේදේන ආරක ප්‍රශ්නයක් කරුද velocity of velocity නෑ තාම නෑ අපි තව චුට්ටක් කරගෙන යමු total energy of a satellite දැන් මෙතන තමයි කතාව තියෙන්නේ total energy of a satellite total energy කියන්නේ මොකද්ද total energy අපිට බලන්න ටියුට් එකේ ගානට ඔයාලට මොකද යන්න තියෙන්නේ total energy is equals to gravitational potential energy plus kinetic energy okay gravitational potential energy plus kinetic energy ඒක තමයි that is the first statement below this first statement බලන්න මේක බලාගන්න then write okay we can write potential energy gravitational potential energy is equals to minus gmm divided by r okay minus gmm divided by r okay kinetic energy is equals to half mv squared but ඔන්න ලස්සන මේකක් තියෙනවා මෙතන v එකට we have an answer for v we can include this here so it will become half gmm divided by r කියලා so this is the kinetic energy then what is total energy equals to minus gmm over r plus half gmm over r now total energy will be minus gmm divided by 2r and make भाग्य मेरे 9 करना making भाग्य 9 करना so we'll have whatever satellite is the satellite's total energy will be minus gmm over 2r and that also means we can go come to some conclusions total energy is minus kinetic energy ki minus उड़ीते total energy का also we can write total energy is half of gravitational potential energy okay නේ ඔන්න මේක ස්ටේට්මන්ට් විදිහට දීලා දිනවා මේක ස්ටේට්මන්ට් විදිහට දීලා දිනවා දැන් ඒක එපා so yeah after this statement හරිද මේ ඔක්කොම ලියන්න අර ගැප් එකේ ලියන්න පුළුවන්ද ලියන්න පුළුවන් වෙයි ඔක්කොම ලියන්නකො අර ගැප් එකේ ලියන්න yeah don't write everything vertically horizontally space එකක් පාවිච්චි කරන්න එතකොට qt is more than enough ඉවරයිද? If you are finished, you can write D7. D7 කියලා දාගත්තා නම් හොඳයි. Okay. Now we are gonna go for some දරුණු කැත what do you call මේක දිවන්නේ. හරි. Next we have period of a satellite. Consider a satellite with an orbit radius r. Consider consider a satellite with a orbit radius r and speed v. If t is the period of whose revolution, අපිට පොඩි දෙයක් ලියන්න පුළුවන්. What is it? In simple harmonic motion අපිට time period ලියනවා නේද? What is time equals to? Simple harmonic motion, circular motion ඔක්කොම ලියනවා we write t equals 2 pi over omega. හරිද? t equals 2 pi r v. Hey, omega is equals to v divided by r. ඔන්න මෙයා මෙතනට දැම්මම t equals 2 pi r v. හරිද? මෙයාවත් ලියාගන්න 1 2 3 මේ තුනම ලියන්න ඕනේ. Okay. So within that gap you're gonna write those. Okay. But when it says consider a satellite with which is with radius r and with a speed v කියලා. Then so using this we can find the time period of any satellite. And velocity එකට එයාගේ radius එක දන්නවා නම් we can find the time period of any satellite. Thereafter මෙතන පොඩි statement එකක් තියෙනවා. මොකක්ද තියෙන්නේ? Proportional relationship between period radius and period speed of a satellite can be found as follows කියලා තියෙනවා. දැන් අතන හරිද? පළවෙනිට දෙකට බෙදෙන්න. Divide the page into two because we have two equations we have to write. Divide the page into two. Okay, divide the page into two. අර්ධක ලියලා divide the page into two. Divide the page into two. මෙන්න මේක තමයි මගේ page එක. හරිද? මේක දෙකට බෙදලා තියෙන්නේ. I'm gonna write t versus r and t versus v කියලා. මෙහෙම ලියාගන්න. Okay. Now let's go through the equation. Okay, let's go through the equation. අපිට ලියන්න පුළුවන් v squared is equal to gm over r කියලා. v squared is equal to gm over r. හරිද? t is equals to 2 pi r divided by v. We can substitute v Oh, actually, we can multiply them. We can what to square this off. Square conjugate, we are getting 2 t squared is equals to 4 pi square r square divided by v square. V squared we are substituting. 4 pi square r cube divided by gm. Okay, t square. Now you can see the proportionality. T squared is proportional to r cube. This is the proportionality, or this is the relationship between time and radius. I mean orbit radius. I mean, this is the relationship between time and radius. අර you මේ derivation එක ලියාගන්න derivation එක ගන්න මේ ගැන ඕන තරම් මේකේ ඇවිල්ලා තියෙනවා MCQ වල. There are enough and more questions about this in the MCQs. That is our left side. Left side මේක අර space එකේ පුළුවන් තරම් left එකේ ඔක්කොම පාවිච්චි කරලා ලියන්න. On the right. On the right we are going to find velocity versus time එක. හරි අපිට දන්නවා අපිට v squared equals මෙතන ආයෙත් ලියන්න gmo r කියලා දන්නවා. t equals 2 pi r d. හරිද? This මෙතන තව එකක් ලියන්න you can subject r එක subject කරන්න උනා. And you can get r equals gm divided by v squared. 2 pi එතකොට මේ r එක substitute කරනවා. r එක substitute කරනවා 2 pi equals gm divided by v times v square කියලා දෙනවා. Until now t is equals to 2 pi gm divided by v cube කියලා. Okay, 2 pi gm divided by v cube. From this we can say time is proportional to 1 over v cube or time is proportional to v to the power minus 3. Okay, time is proportional to v to the power minus 3 and time is proportional to actually time square is proportional to r cube. फिर मैं ඇත්තටම ලියනවා නම් time is proportional to r3 to the power 2, 3 over 2. r to the power 1.5 තමයි. මෙතන උත්තරේ. Because again you are rooting it. So r to the power 1.5 තමයි මෙතන ඉන්නේ. Okay නේ? Now take time and write this 2 pages. ඊට පස්සේ done කියලා message එකක් දාන්න. Okay, so yeah, that is time period related makeup. Now we have something called geostationary satellites. As the geostationary satellites. The fun part about geostationary satellites is there are a few things. Number one, geostationary satellites will always work on an equator. Equator के चुट्टा के हाथ गया किला पैदा करने ने. Geostationary satellites do not lock their position. And geostationary satellites are satellites that lock position with lock a position with the Earth. The Earth के position එකක් lock කළා. ඒ කියන්නේ ශ්‍රී ලංකාව උඩ geostationary satellite එකක් තියෙනවා. That won't go anywhere else. It will be moving with the Earth and it will be always facing Sri Lanka. Sri Lanka again Kandy or something. So it is focused to Kandy and it will be rotating around Earth such that it will be always focused on Kandy. Those kind of satellites are called geostationary satellites. Orbital period of a geostationary satellite is 24 hours. Orbital period of a geostationary satellite is exactly 24 hours. On a t equals 4 pi r square r cube මේක තියෙනවා නේද? For this මේ t square එක දන්නවා. To apply everything every single answer and find r cube and then you root it. අපිට හරියට එනවා 42,400 kilometers කියලා. Okay, 42,400 kilometers. මේකට වඩා radius එක අඩු වැඩි වුණත් if the radius is greater or less than this, it will not lock position with the Earth. It will not be a geostationary satellite. Geostationary satellite have a strict rule of maintaining between at a small difference, small difference around 42,400 kilometers from center of the Earth. From the center of the Earth. Okay. In that 6,400 kilometers is what do you call 6,400 kilometers is the curvature, is the radius of the Earth. It will be running at 36,000 kilometers from the surface of the Earth. 36,000 kilometers from the surface of the Earth. Geostationary satellites locate වෙලා and at the equator. So it is small belt. Or asteroid belt එකක් තියෙන්නේ solar system के asteroid belt එකක් තියෙන්නේ after Mars. Similarly, around at the planet, හරියට ring එකක් හරි ring තඩි ring එක, okay? Yeah, it is at this point completely filled with satellites. There are a set of geostationary satellites exactly at the equator. And එයාලා මේ ගොඩාක් දාලා එයා මේ geostationary satellites angle කරලා තියෙනවා. එහෙම angle කරනකොට what will happen? මේවනේ satellite එක තියෙන්නේ. When you angle the satellite, මේ වගේ angle එකක් තිබ්බා නම් you can see a certain amount of area. එහෙම cover කරන්න පුළුවන් ගොඩාක් area, most of the area of the Earth. Except for the polar regions. Polar regions වෙන්න බෑ. Polar region එකට we have a polar orbiter. Polar orbiter it is not geostationary, but what will happen is it will scan it runs at 24 hours. Yes, it runs every 24 hours. හැබැයි at 24 hours එකේ it is going to cover up one time zone. You can remember what time zones are, right? It's not exactly 24 hours, it is a bit less than 24 hours. So it will actually take 24 days to cover up a time zone. The time zone cover color, you know. Okay. Next, the final thing we have, final theory for today is something called escape velocity. Okay. Eka karana, we have finished gravitational fields. We will be doing, I mean, me homework sticker current one nati way. Okay, let's see. Okay. I'll be doing some and then rest sticker I'll give you as homework. Okay. And then tomorrow we have a huge tute to complete. Huge past paper questions, past paper essays हुक्म complete करना तीनों. Escape velocity. इधर note लिया करना in those dotted lines. What is escape velocity? The minimum velocity with which the minimum velocity with which the minimum velocity with which an object should be projected. The minimum velocity with which the object should be projected from the surface of a planet so as to leave the gravitational field of a planet. Given the minimum velocity with which an object should be projected, an object should be projected, an object should be projected from the surface of a planet. An object should be projected from the surface of the planet. From the surface of a planet. So as to planet. So as to leave the gravitational field. Leave the gravitational field. So as to leave the gravitational field of a planet. Of a planet is known as escape velocity. ඒක ලිව්වත් එකයි නැතත් එකයි. හරිද? Let's do a diagram for that. Okay. Let's do a diagram for the last theory. We have Earth for now, and this is a point called infinity where gravitational field is 0. We'll call this point P and this point as Q. Energy at Q equals energy at P. ඔන්න අර mechanics ප්‍රශ්න තමයි යන්නේ. Energy at P. Energy at Q is minus gm divided by r square r plus half mv squared is equals to 0. Because at P there is no velocity because it has exceeded the, I mean, it's an escape velocity. So we are trying to find the minimum velocity here. That should be here in order, that should be here in order to for the, in order for the object to be in a place where gravitational field doesn't act. Now we can equate this. Half mv squared equals gmm divided by r. We can cancel off m. Instead of gmr, we can actually write, actually no, we are going to write v squared is equals to 2gm. Actually, v is equals to 2gm divided by r. ඒකත් එක්ක පල්ලෙ ලියන්න gr is equals to gm over r. Therefore, v is equals to 2gr. V is equals to 2gr. Okay? V is equals to 2gr. Now there's another story. R here is the radius of the planet. If a satellite is traveling around the globe at a distance 1 kilometer from the surface of the Earth. Okay, 6,400 plus 1 kilometer would absolutely nothing. It's almost again equals to 6,400 kilometers. හරිද? ඒ වගේ වෙලාවදී satellites velocity will be gr නේද? If a satellite is moving 1 kilometer on the has an orbit of 1 kilometer from the surface, again is velocity is approximately equals to gr neda root gr neda. මේ r කියන්නේ 6400 plus 1 වැඩක් නැහැ when you are talking thousands. So make a, if you think properly, make a root 2 times තමයි මෙයා. Make a root 2 times තමයි මෙයා. මේකත් මතක තියාගන්න, they continuously they have been asking this part as well. How many times the velocity is the escape velocity compared to the velocity of a satellite orbiting on the surface of the planet කියලා කියනවා. Or orbiting close to the surface of the planet. Close to the surface of the planet means tangential velocity will be root gr. And the escape velocity of that will be root 2 gr. Okay නේ? මේවා ලිව්වට පස්සේ put as d8 කියලා දාන්නකෝ. d8 කියලා දැම්මා. We are going to do questions. Done කරලා message එකක් දාන්න after you have finished. Okay. From that, the theory is finished. Theory is finished. Now let's do some questions. First of all, let's do 1 or 2 questions from do the 5th question. Everybody do the 5th question. 5th question in Karanda. Do the 5th question. I'll give you exactly time till 5 or 5. Have I calculated engine? I'll give you time till yeah around 5. We are doing the fifth question. Okay. Um, I'll start doing the question. Um, um, fifth question. Okay. Fifth question. You completed. I'll start doing it. How satellite of mass 500 kilogram is an orbit around the Earth at a distance r above the surface of the Earth, where r is the radius of the Earth. How close is centripetal force? Centripetal force. We have satellite. Wait, what is the centripetal force of the satellite? Centripetal force is given by, or centripetal acceleration is given by gravitational force. So we can direct like centripetal force is equal to gmm over r square. We have gravitational acceleration 2 or 3 times 10 to the power minus 11. This is not the actual value, just a temporary value for you to make the sums easier. Mass has become 6 times 10 to the power 24. 500 kilogram satellite. 6,400. Actually, we can write it as 64 times 10 to the power 35 square. How can we do this? Cancel off 3 first. We have 2 left. It was, we can add another 0 here. Navigate current belong 2.5 multiply color 10 color. You can cut it and put another 0 somewhere. Then we have 2 times. We have 2 over 64 times 64 times 10 to the power minus 11 times 10 to the power 24, 26, 27 divided by 10 to the power 10. मैं करूँ minus 21 करूँ. You are left with 1 over 32 times 64 times 10 to the power minus, not actually minus, um, 6. This is a large area. This is a really large area. Shall we check? Um, make cuts and oh 500. We are talking about 500 kilogram. Satellite of mass 500 kilogram. මෙතන කෙලින්ම mass දාන්න මෙතන newtons මේකද? Okay, what I did was මෙතන we had a multiplication of 2 and 5. Okay, may 2 and 5 kapala we can get it as 10 ne, because 2 times 5 is 10 ne. ඒ 10 එක මෙතන දැම්ම නම් කෙලින්ම zeros වලට multiply කරන්න පුළුවන් නේ. That's what I did. Okay, නැත්නම් මේ 10 එක මෙතන ලියා ගන්න. Then we don't have to worry about it too. හරිද? Not necessary in this sum, but there are some sums, mainly surface tension. ඔක්කොම ballistic අර r to the power 4 එකක් ආවම 2s ඔක්කොම පැටලෙනවා. හැමතැනම 2s තියෙනවා. ඒ 2s ඔක්කොම cancel වෙනකොට එක 2 එකක් miss වෙනවා. That's why we do this. Okay. It's a good practice. That's only I'm going to say. If you want, yeah. This is going to be 4.88 times 10 to the power minus. Actually, it's 10 to the power minus 4, so 10 to the power 2 newtons. This is the force, centripetal force acting on the surface. Thereby calculate the tangential velocity. Tangential velocity can be written as Fc is equals to mv squared over r. Nice, ne? mv squared over r now. Nice. What can we do? What can we actually do is, okay, I'll give you this advice. May advice එක මතක තියාගන්න. Always don't go with your final answer. ඔන්න මේකට FCR දාන්න තියෙනවනේ. Don't go with your final answer. Go with an initial step you used. මෙයාව පාවිච්චි කරමු. Okay. Now see, we can write 2 64 times 64 times ඕනේ නම් මෙතන ඉන්නේ 10 to the power 6 නේ. මේව කරලා ලියන්න උනා. අවුලක් නැහැ. Therefore cut marks for this. මේක ලියලා මෙතන දාන්න. මේක දාන්න. Then we have mass is 500. We don't know v squared, but we know the radius. Only 64 කැපෙනවා. Beautiful. Only 64 කැපෙනවා. We have another 64. We can actually make it a 32. We can make it a 32. Then make 10 to the 5. එතන කපලා we can make it 10 to the power 3. What else can we do? That's all. V squared is equals to 32 times 10 to the power 9 divided by 5. May divided by 5 එක divided by 5 එක we can write it as fraction. What fraction can we write it as? 10 divided by 2 කියලා නේද? 10 divided by 2 නම් we get 64 times 10 to the power 8. 6.4 times 10 to the power 7. This is our velocity. That is still not our velocity. Actually, this is our v squared value. Tangential velocity will be 8 times 10 to the power 4. Our answers are in standard units. Okay. May simplification තේරුණානේ? I hope simplification එක තේරුණා කියලා. Next what can we do? Calculate the gravitational potential energy of the satellite. Calculate the gravitational potential energy of the satellite. Gravitational potential energy of the satellite. U equals minus GMM over R. Minus GMM over R. We found the value of GMM over R squared. Ne? Actually, we found the value for GMM over R squared. So we can directly use this. 2 divided by 64 times 64 times 10 to the power 6. Okay. What is the only difference? Here there's a R squared නෙමෙයි මෙතන තියෙන R. මෙයාව minus කරලා you then multiply by R. අවුලක් නැහැ. You multiply by R, that will give you 64 times 10 to the power 5. 64 gets cancelled off. You are left with 32. Okay. 1 over 32 is somewhat equals to 3.125 times 10 to the power minus 2 times 10 to the power 11. So we can directly write 3.125 times 10 to the power 9 joules is our final answer. Okay, ne? This is the gravitational potential energy of that satellite. Kinetic energy. Okay, now I actually used this question. I actually used this question to show you that total energy is equals to minus gravitational potential energy. Total energy is equals to half of gravitational potential energy and is equals to minus of kinetic energy. එහෙම කියලා තියෙනවනේ. හරිද? ඒක හදන්න තමයි ඒක prove කරන්න තමයි I gave you this question. Now by this question you would have got kinetic energy as by doing some simple some calculations you would have get it as 1.1 5, 6, 2 times 10 to the power 9 joules kilogram. What is this? This is the kinetic energy. And the total energy would have been what? And minus kinetic energy plus total energy would have been same 1.5620 times 10 to the power 9 joules. But it is the minus value. Okay? Values into the if you have noticed it, you would have directly found it, but if you didn't notice it, you would have done the entire half m squared equation එහෙමත් හොඳයි. මේ හදනකොට තමයි තේරෙන්නේ this is half කියලා. Okay, now that's done. Now let's do 23. 23 කරන්න බලමු. Do the 23rd question. 23rd question එක කරමු. 23rd question. Body is released from height equal to radius r of the earth. Velocity of the body when it reaches the surface. How do you do it? How do we do this? Using energy conservation. You have to use energy conservation. By that, what would you get? Shall we do this question? I hope you have done this question. Shall we allow Janne? මේකට නම් okay, 26th question. Actually, is it 26? Actually, 23rd question. 23rd question. What did I give you? 23rd? I should have given you 23rd. Hopefully. මට මතක නැහැ. 26 කියන එක සමහරට ප්‍රශ්න ආවනේ. What is 26? 23rd question. Energy conservation. Energy at surface is equal to energy at radius r. What is energy at surface? Actually, energy at radius r is equal to energy at surface. What is the energy at radius r? Minus gmm divided by 2r. What is the energy at surface? Minus gmm divided by r plus half mv square. We can cancel off some values. M gets cancelled off. That's it. Then we can write v squared between the curve is equals to gm divided by r minus gm divided by 2r. Actually, yeah, v squared will be equals to gm divided by 2r times 2. We can directly get V squared is equals to GMR. May I root take? Is there answer there? Yes, that answer is there because G is equals to gravitational acceleration is equals to GM over actually GR is equals to GM over R. GM over RT now. And so we can directly write GR. Root GR here. Okay. Do you have any questions? No, I don't think so. That is the 23rd question. 24th Kerala. Do the 24th question and put it onto the chat. The answer for 24th question. Yes, 24. Yes, 24 is the third answer. Yes. Because what happens? They are asking for potential energy compared to total energy. Potential energy is two times. Ne? Potential energy is two times. Hey, abhi then kare. कोई तो करें. Okay, I erased it. Ne? It is two times E. E by two times the total energy. No sign deviation. But tiny energy, there's sign deviation. Ne? So it should be the third answer. Calculate the amount of work needed to shift the satellite to a higher orbit of radius 3R. Okay, to the 25th question. 25th current baram. Do 25th question. Rest of them I'll give you as homework. 25th, do. Rest of them I'll give you as homework. 25. Okay, 25 is simple. I'll also do that. Um, we have calculate the amount of work needed to shift the satellite to a higher orbit from an orbit radius of 3R to an orbit radius of 4R. අපිට තියෙනවා a satellite at 3R. We are shifting it to 4R. What changes? Energy, ne? Energy and velocity changes. They are asking for amount of work done. Amount of work done doesn't depend on energy. Sorry, kinetic energy. It only depends on potential energy. Has a gravitation potential energy. අපිට කිනිවන් නියන්න උරන් changing gravitational potential energy is equals to minus GMM 1 over 4R minus 1 over 3R. Actually, that's wrong. 3R minus 1 over 4R. Minus GMM 12 R කියලා දාගන්න පුළුවන්. This will be 4 minus 3. So you will directly get GMM divided by 12R. එහෙම උත්තරයක් තියනවාද? Not yet. We have to go through මෙයා substitute කරන්න බලන්න. මෙයා substitute කරන we will directly get mgr divided by 12. Is our final answer. That is the third answer. For 25th also third answer. 26th කරන්න බලමු. A satellite of Earth is traveling in a circular orbit with velocity v. The gravitational force suddenly disappears. Satellite එකට මොකද වෙන්නේ? What will happen to the satellite? Satellite is orbiting around the planet. Suddenly the planet disappears. What will happen to the satellite? That is the question. Number 1. Continue to move in a circular orbit. Where's the centripetal force? It can't be. Suddenly become stationary. Where's the deceleration? Deceleration එකකින් දෙවියක් නැහැ. Move with a velocity v tangential to the original orbit. Yes, what happens? මේ orbit එකේ මේ move වෙන එක්කෙනාට එකපාරට gravitational field නැති වුණා නම් it will start to move tangential to the place it left. Okay? It will start to move tangentially. What do you have next? Okay, so that is the answer. Will decelerate and come to rest? Obviously no. None of these නෙමෙයි. Third one is the answer. So yeah, so that is the answer. Shall we do an earlier question? Actually, wait. So wait. We did. What did we do? The 21 and 22 was homework. 23 to we did 23, ne? 23 to 26 we did. 27 to 32. We'll try to finish this as much as possible. We did 1, 5. We have to do 2, 3, 4. We'll do one more question and wind up the session because there's not many people. Ne? So we'll wind up the session. And tomorrow we will discuss kala past wave discuss kala. Okay. We did the 10th question. We did the 10th question. Try the 11th question. 11th question is a mix of gravitational field and the simple pendulum. Try the 11th question. Try the 11th question. We no. Okay. You continue the question. Exactly at 3:30. Actually, not 3:30. I'll give you the answer. Okay, let's continue. The 11th question. 11th question is simple. Okay, 11th question. What do we have? We know T is equals to 2 pi root L over G. This is the simple pendulum. Then we can say T is proportional of 1 over root G කියලා. එහෙම එකක් තියෙනවා නේද? Now G using gravitational acceleration we can write gm over r squared කියලා. Okay නේ? ඔන්න එයාවත් ලියලා දාමු. Then T is proportional to root 1 over root gm over actually we can write this actually as r squared over gm කියලා because inverse නේ r squared over gm ගේ root. ඕන්න බලන්න T is proportional to r කියලා එන්නේ. ලස්සනයි T is proportional to r. T dash over T1 is equals to T dash එකට අපිට දන්නවා this is r over 2 කියලා. T1 එකට r. Okay? R gets cancelled off. T dash is equals to T1 over 2. This is I'm really sorry. It says from the surface. From the surface now මෙයාට තව r එක add කරන්න ඕනේ නේ. So it should be 3r over 2. 3r over 2 නම් T dash is equals to 3 over 2 T1. Answer number 4. Answer number 4. Okay? That is the fourth answer. So that's it for today. Your homework is මම ලියලා දාන්න මෙතන. Homework is 2 to 4. 2 to 4, 8, 9, 12 to 18, 21, 22, 27 to 32. Do this and come tomorrow. Let's do the session tomorrow. That's it for today.